Hello, my name is Karen Gondoli and I am the CEO of Leostream. Today I want to talk about how the Leostream platform can help you control costs when you're deploying VDI in a public cloud such as AWS or Azure. First of all, let's talk about why this is a problem. Well, it really comes down to two things. It's about power state and capacity. If you leave machines running when users don't need them, or you over provision because you're not sure how many users are going to need them, then that's going to lead to increased costs in the cloud. And the problem is that often IT teams are trying to manually manage that power state and capacity, and when you're looking at the cloud management platforms themselves, you don't have visibility into who's actually using machines. So you don't know how to do that manual management. So the key really is to realize that it's actually about access control. Users require access to these compute instances in the cloud so they can get their job done. But if you have poor access control that doesn't automate access, then you will end up with over provisioning of capacity and you will end up with running instances that are actually idle. So what you need is automation. And that's what the Leostream platform gives you, is a way to automate access control so you can achieve cost control. So what we can do is allow you to power on desktops based on demand, and that demand might just be based on time of day or based on user's role, you decide. And what we can also do is automate powering off machines when users are done. Maybe that's after they're idle, maybe that's after logout. Again, you have ways of configuring that based on your business needs. And it's the Leostream platform automates not just power, it also automates capacity. You have our pooling that allows you to provision machines, and then our release plans that allow you to terminate them based on, again, could be schedule, could be role, whatever works best for your institution. And what you also get with Leostream after you've automated all this access control is increased visibility. You know who's using what resource from where for how long. You can see if they're going idle, and you can track these patterns over time so that you can actually plan for the future better, so that you know when you should be provisioning from pools or you know when you should be powering on and off machines. And in the end, what this gives you is more predictable costs and optimized resource usage in the cloud without requiring IT to do these manual processes. So IT is simplified, the end user experience is consistent, and your costs go down. It's a win all around. So let's just show some of the things you can do within Leostream with an example. This is the Leostream Connect client. So I'm just going to log in here as an end user. I happen to be offered two machines. I'm going to simply connect to my RDP connection here. And I'm just going to let this connect. It's going through the Leostream gateway into the private VPC in AWS to connect to this machine. And now I'm just going to minimize it. Essentially, that means that machine is going to end up going idle because there's no keyboard or mouse movement. So now let's see what's going to happen to that machine based on the rules I've made in my Leostream connection broker. So now I'm going to log in as an admin to the Leostream connection broker. I can first see here in centers, AWS Ohio happens to be the region that that machine is running in, but through this one connection broker, I'm actually managing my cloud resources in AWS Ohio, also in AWS in Ireland, and even in Azure in US East here. So from with this one interface, I can manage power state, access, capacity across all these clouds. Now, what you'll see is I created a pool. That RDP desktop came from this RDP Ohio pool. And if I edit that, you'll see inside pools is where I can automate some of my capacity management. So in my simple example, I'm saying I want to have always two machines running in that pool and no more than three. And again, you can set these limits to whatever you need them to be. And those are static limits, but you can also do it based on, again, day and time. So if you have classrooms, for example, you can actually just spin up machines when the class starts ahead of time. So these provisioning limits in pool allow me to automate when do I create capacity. And the provisioning parameters then say how is the broker going to spin up that machine, the instance type, the AMI, things like that. So pools help me define capacity. My user was actually offered a desktop from that pool through this policy here, the DCV RDP policy. So if I look at the RDP Ohio pool in this policy, it's assigned the release plan, release on idle, and power off on release. Here's where you get the other half of capacity management, which is terminating machines, plus your power control. So if I look just at the release plan, for example, this form is broken into sections, and they're sections based on information that comes from the Leostream agent installed on that Windows machine. So if I had disconnected instead of minimized after 15 minutes, the machine would have been released from the pool. But I'm still connected, so the agent is actually monitoring for idle. Now in my example, I'm saying log out after 2 minutes, and that's good for this demo, but probably not what you want. But you have many options here to say how long can the user remain idle before you log them out. And you can even suspend that based on CPU in case the user is running a process in the background while not monitoring and moving their mouse. Now, what you didn't notice over here on my other screen is my RDP connection is now closed because 2 minutes has gone by. And that logged me out, which closed my RDP session. And that logout invoked this section of the release plan, which then releases the machine back to its pool immediately. When released to the pool, that's going to trigger this part of the release plan. Here is where, if I wanted a non-persistent workflow, if I wanted to terminate or delete that machine, I could do it using this option here. In my case, I didn't terminate the machine, but I wanted to power it down. That's where the power control plan comes into play. Here in the power control plan, it's invoking this power control plan, which says after the machine is released, go ahead and shut it right down. Now, if this was an Azure machine and I shut down, that would take it all the way to a deallocated state as well. Now, the handy thing here is in the system log page, I have a running tally of all of this as it goes on. So if I look, I can see when the user logs in and is connected. Here's my login, I'm connected. And then I can see the agent letting me know that the user's gone idle, which logs them out, closes the forwarding rule that's in the gateway so that I have that secure access for my user without leaving ports open after they're disconnected or logged out. And I can see the machine getting released and then ultimately shutting down. So that is just one example of how you can use the Leostream connection broker and the platform at large to help you manage costs and capacity within the public cloud. If you want to learn more, you can contact us at info@leostream.com. Thank you.